Hi, this is Dana Maier. I am doing my week 1 assignment for Material Methods 2. This is on the basics of concrete. First, we'll talk about cement and concrete. Cement is a binder. It's a substance used for construction that sets, hardens, and adheres to other materials, binding them together. Cement is seldom used on its own, but rather to bind sand and gravel together. Portland cement is the basic ingredient of concrete, and the most common way to manufacture is through a dry method. Common materials used to manufacture cement include limestone, shells, and chalk, or marl combined with shale, clay, slate, blast furnace slag, silica sand, and iron ore. And when heated at high temperature, it forms a rock-like substance that is ground into a fine powder that we commonly think of as cement. Next, we will talk about aggregates and water. Aggregate is classified as two different types, coarse and fine. Coarse is usually greater than 4.75 millimeters and retained on a number 4 sieve. Fine is less than 4.75 millimeters and passes through a number 4 sieve. Recycled concrete is a viable source of aggregate and has been satisfactorily used in granular subbases, soil cement, and in new concrete. Cement is seldom used on its own, but rather to bind sand and gravel together. Concrete is a mixture of cementitious material, aggregate, and water. Aggregate is commonly considered an inert filler, which accounts for 60 to 80% of the volume and 70 to 85% of the weight of concrete, and it is a necessary component that defines the concrete's thermal and elastic properties and dimensional stability. Its shape and texture affects the properties of fresh concrete more than hardened concrete. Surface texture can be smooth or rough, and the moisture content of an aggregate is an important factor when developing the proper water-cementitious material ratio. Next, we will talk about supplementary cementitious materials, or SCMs. There are a few types of SCMs we'll mention. There's fly ash, slag cement, silica fume, and natural pozzolans. Other factors to consider are the reactions, the effects on concrete, and proportioning. And SCMs are used in at least 60% of ready-mix concrete. They are pre-consumer material, and the shape and texture of aggregate affects the properties of fresh concrete more than hardened concrete. We will now talk about admixtures. They are added to concrete batches immediately before or during mixing of concrete. Admixtures can improve concrete quality, manageability, and acceleration or retardation of setting time, among other properties that could be altered to get specific results. Many concrete mixes today contain one or more concrete admixtures that will help your pouring process, driving down cost while increasing productivity. The cost of these admixtures will vary depending on the quantity, and the type of admixtures being used. Additionally, all of this will be added to the cubic yard or cubic meter cost of concrete. We will now talk about making and placing concrete. First, there's proportioning concrete mixes. Step 1 is choice of slump. Step 2 is the choice of maximum size of aggregate. Large maximum sizes of aggregates produce less voids than smaller sizes. Step 3, we have the estimation of mixing water and air content. The ACI method uses past experience to give a first estimate for the quantity of water per unit volume of concrete required to produce a given slump. The ACI method is based on the principle that the maximum size of aggregate should be the largest available, so long as it is consistent with dimensions of the structure. Next, we have the handling and the placing of concrete. With handling, the main objective is to prevent segregation and controlling moisture of the material. Segregation problems can be minimized by storing coarse aggregate in coarse, medium, and fine fractions. This will allow the proper gradation of the aggregate. Additionally, protection from the weather can prevent wide variation in moisture content. With the placement of concrete, we should minimize the segregation of coarse aggregates. Basically, concrete should be placed by a vertical drop. However, the material should not be allowed to free fall for long distances. Concrete should be allowed to flow slowly into the forms at a vertical angle, and if placement on a slope is desired, concrete should be constrained to fall vertically by some sort of chute or baffle. We also have special placement of concrete. There is slip forming, pre-placed aggregate, shot creating of knitting, and trimming concrete, and one way of that is underwater placement. We will now talk about curing concrete. Curing is the maintaining of an adequate moisture content and temperature in concrete at early stages so it can develop properties the mixture was designed to achieve. Curing begins immediately after placement and finishing so that the concrete may develop the desired strength and durability. Curing concrete will make your concrete stronger and better, but only if you do it right. Timing is key. We will now talk about formwork. Formwork is the temporary or permanent molds into which concrete or similar materials are poured. In the context of concrete construction, the falsework supports the shuttering molds. Formwork comes in several types. There is the traditional timber formwork, and it is built on site out of timber and plywood or moisture-resistant particle board. We have the engineered formwork system. This formwork is built out of prefabricated modules with a metal frame, usually steel or aluminum, and covered on the application side with materials having wanted surface steel, usually steel, aluminum, and timber. Additional types of formwork are stay-in-place structural formwork. This formwork is assembled on-site, usually out of prefabricated fiber-reinforced plastic forms. These are in the shape of hollow tubes and are usually used for columns and piers. There's also the flexible formwork. In contrast to the rigid molds described previously, flexible formwork is a system that uses lightweight, high-strength sheets of fabric to take advantage of the fluidity of concrete and create highly optimized, architecturally interesting building forms. We also have reusable plastic formwork. These interlocking and modular systems are used to build widely variable but relatively simple concrete structures. And the last one we have is the permanent insulated formwork. This formwork is assembled on-site, usually out of insulating concrete forms, also known as ICF. We'll now talk about reinforcing. Reinforcing in concept, it is the pre-stressing concrete as a technique that will greatly increase the load-bearing strength of concrete beams. Reinforcing steel in the bottom part of the beam, which will be subjected to tensile forces when in service, and it is placed in tension before the concrete is poured around it. With reinforced concrete, it is a composite material in which concrete's relatively low tensile strength and ductility are counteracted by the inclusion of reinforcement during higher tensile strength or ductility. With reinforcing, there are certain needs that have to have the following properties. You want a high relative strength, high toleration of tensile strain, good bond to the concrete, irrespective of the pH, moisture, or similar factors, thermal compatibility, not causing unacceptable stresses in response to changing temperatures, and durability in the concrete environment, irrespective of corrosion or sustained stress. Another factor in reinforcing are steel bars being used for concrete reinforcement. First, we have rebar, which is short for reinforcing bar. It is collectively known as reinforcing steel and reinforcement steel. It is a steel bar or mesh of steel wires used as a tension device in reinforced concrete and reinforced masonry structures to strengthen and hold the concrete in compression. Rebar is used in concrete to provide additional strength as concrete is weak in tension, while steel is strong in both tension and compression. Steel and concrete have similar coefficients of thermal expansion, so a concrete structural member reinforced with steel will experience minimal stress as the temperature changes. Other factors with reinforcing are reinforcing concrete columns. It is a structural member designed to carry compressive loads composed of concrete with an embedded steel frame to provide reinforcement. For design purposes, the columns are separated into two categories, short columns and slender columns. We also, in reinforcing, have fibrous reinforcing, which is also under Master Format Section 032400. Fiber reinforced concrete, or FRC, is concrete containing fibrous material which increases its structural integrity. It contains short, discrete fibers that are uniformly distributed and randomly oriented. We'll now talk about concrete creep. Concrete creep is when concrete is loaded, the structure undergoes elastic and inelastic deformations. Elastic deformations occur immediately after the concrete is subjected to a given load according to Hooke's law. Inelastic deformations increase with time as the concrete experiences a sustained load. We will now talk about pre-stressing. Pre-stressed concrete is concrete that has had internal stresses introduced to counteract, to the degree desired, the tensile stresses that will be imposed in service. The stress is usually imposed by tendons of individual hard-drawn wires, cables of hard-drawn wires, or bars of high-strength alloy steel. Pre-stressing may be achieved by either pre-tensioning or by post-tensioning. Pre-tensioning may be achieved by either to pre-tension concrete steel is first tensioned in a frame or anchorages external to the member. The concrete is then cast around it. After the concrete has developed sufficient strength, the tension is slowly released from the frame or anchorages to transfer the stress to the concrete to which the tendons have by that time become bonded. The force is transmitted to the concrete over a certain distance from each end of a member known as a transfer line. Post-tensioning. Post-tension concrete is made by casting concrete that contains ducts through which tendons can be threaded. An alternative is to cast the concrete around tendons that are greased or encased in a plastic sleeve. When the concrete has sufficient strength and the tendons are tensioned by means of portable jacks. One advantage of post-tensioning is that it permits the using of tendons that are easily curved or draped. This can be achieved by pre-tensioning, but not so easily. Post-tensioning can be done on the job site without any need of heavy temporary anchorages. Anchorages are needed for each tendon, however, which is a significant cost item. We will now go into some specialty areas, one of which is concrete stairs. First part of concrete stairs is to figure out the size of your concrete steps. Before you start building concrete steps, check with your local building codes to make sure you comply with any dimensions they require, and also keep in mind that you'll need to look into what is required for handrails. Step 2 is preparing the base, and it is a very important step when building concrete steps. After you know the rise and the run of your concrete steps, you can decide on a width. The width should be at least 6 inches wider than the doorway on each side. Step 3 is building the forms for the concrete stairs. You can use either 3/4 inch plywood, 2x8s, or 2x6s to build the forms for the concrete stairs. The rise and the run of the stairs will determine which material is best to use. Before you start building concrete steps, just make sure you've double checked on the building codes. Step 4 is pouring the concrete into the concrete stairs. Building concrete steps can be done by mixing the concrete bags you buy or calling a ready mix company and having them deliver the concrete pre-mixed on a concrete truck. Step 5, finishing the concrete after it has set up. When learning how to build concrete steps, putting the final finish on the concrete is key to having a nice looking set of stairs. The concrete should be dry enough so no water is visible on the surface of the concrete and moist enough to work up some cream when you trowel the surface. And the final step is step 6, cure the concrete by keeping it wet. After finishing the process, let the concrete set overnight. The next day, remove the side forms, patch any voids with a concrete match material, and keep the concrete wet by hosing it with water. The longer you keep it wet, the better it is for the concrete. Approximately 2 to 5 days, if possible. Now we will talk about site cast post-tension framing systems. Post-tension framing systems can be applied to any of the site cast framing systems. It's often used in parking garages, and other types of post-tension systems are casting a concrete slab on grade, casting a concrete wall, casting a concrete column, one-way floor and roof framing systems, or two-way floor and roof framing systems. Now we will talk about selecting a site cast concrete framing system. With selecting a site cast concrete framing system, the first thing is when choosing a structural system for a building, you must first determine the range of the structural systems that the relevant building code allows. Additionally, each of the model building codes on which most North American codes are based requires you to do this by determining the first use group into which the building falls, then consulting tables, formulas, and numerous detailed provisions of the code that prescribe the maximum height and floor to which a building code of a given use group may be built using each of the range of code-defined construction types. We will now talk about innovations in site cast concrete construction. There are several types of innovations. We have concrete filled steel tubes, self-compacting concrete, RPC structures, compact reinforced composite, foamed concrete, and recycled aggregate concrete. We will now talk about architectural concrete. When we talk about architectural concrete, we're referring to the concrete that, while providing an aesthetic finish to the building, also serves a structural function. Decorative concrete typically refers to concrete, flatwork, or building elements such as panels that, while enhanced with texture or color, are not structural building members. Next, we will talk about cutting concrete, stone, and masonry. There are 3 types of methods that can be used. Method 1 is a chisel and hammer. Method 2 is a powered saw. And method 3 is a splitter. And here are my references, and I thank you for watching and listening to my presentation. Thank you.